Okay, you guys, today we are going to continue working with the unit circle. We're dealing with trig functions in the unit circle. And our objectives are to use the properties of the special right triangles to evaluate trig functions in the angles or of angles within the unit circle. Let's first start with reviewing our special right triangles. Remember, there are two types. The first one is the 45, 45, 90 right triangle. And remember, in a unit circle, your triangles are always with the hypotenuse of 1. Okay, so the hypotenuse is 1. Can we find the sides of this 45, 45, 90 right triangle? Remember, from the hypotenuse to the sides, you divide by radical 2. So 1 divided by radical 2, you have to rationalize it, and that's what you get. Okay, you get radical 2 over 2 for both sides. The other type is the 60, 90 right triangle. Okay, remember again, the hypotenuse is 1, so the short side is half of that, which is 1/2. And the long side is 1/2 times radical 3, which is radical 3 over 2. So that's just a quick review of the special right triangle. You should know how to find these guys, okay? But in trig, you gotta really know these guys. So the best thing you can do is memorize these. Basically, just memorize the lengths of your two types of right triangle, okay? But right now, seeing that it's still new, you guys want to have these in front of you at all times as you're doing this lesson today, okay? So have these two triangles in front of you all the time today. All right, so let's go on to an example here. They want you to find cosine of 45. That's what they meant by trig functions. They want you to find sine, cosine, tangent of things. Okay, they want cosine of 45 degrees. Let's make 45 degrees in our unit circle. And basically, you want to find the point on that unit circle there, looking for the x and the y. Okay, you guys know how to do this. We draw toward the x-axis, right? There we have a triangle. What does that triangle look like? It looks like a 45, 45, 90 right triangle, right? So I'm looking back at my two types of triangles earlier. That's the one I want to look at, the 45, 45, not the 30, 60, obviously. So there I have that little triangle in there looking just like that. So I can transfer the numbers over the base and the height of this triangle here. Now I know the x is the base and the y is the height. So my x and my y turn out to be radical 2 over 2, both of them. Now from there, I can go and evaluate my cosine. Here, let's say cosine of 45, right? Cosine of 45 is cosine of this angle here. You're always using the reference angle. Always use the reference angle. So cosine of this means adjacent over hypotenuse. So radical 2 over 2 over 1, which is radical 2 over 2. If they want sine, then you look at the opposite. So you take this thing, put it over 1, which is just this thing, okay? Radical 2 over 2. If they want tangent, you take opposite over adjacent, okay? Opposite over adjacent, so you have this thing over this thing. So tangent is just radical 2 over 2 divided by radical 2 over 2. Same thing over the same thing gives you 1. All right, let's go on to another example here. They want sine of 30. We draw 30 degrees, and then we draw toward the x-axis, right? To find the x and the y there. And then so here, what kind of triangle do you think we should use? Should we use the 45, 45, 90? Or should we use 30, 60, 90? Obviously, it's 30 here, so I want to use the 30, 60, 90 right triangle. And from there, I'm going to try to transfer these numbers over. But I have to be careful because it looks like the triangle is flipped. Okay, so I have to see, oh, which side is the short side, which side is the long side, right? So I kind of do this rotation in my head, sort of, how do I flip it so it looks the same now? See, I flip it this way and I move it over like that, right? So now the short side is over here, which is the 1/2, and the long side over here is the radical 3 over 2. So from there, I know, oh, 1/2 goes there, radical 3 over 2 is there, and that gives me my x and my y, see? The base is my x, the height is my y. So x and y are there. I have radical 3 over 2 for x and 1/2 for y. Now they want sine, right? Sine of my reference angle. Sine is opposite over hypotenuse. So I have 1/2 over 1, which is just 1/2. Now if they want tangent, again, tangent is opposite over adjacent, right? So I have 1/2 over radical 2, or radical 3 over 2. It's 1/2 divided by radical 3 over 2. That means I take the top fraction, multiply by the reciprocal of the bottom fraction, because remember, you're dividing fractions, so you keep flip change, right? So 1/2 times 2 over radical 3, which gives you, cross out the 2, I get 1 over radical 3, which I have to rationalize, gives me radical 3 over 3. Okay, in this example, they want you to find sine of something monstrous here, right? So you look at this and you're like, ooh, what is this? But it's really not that bad. First of all, let's look at this negative sign. All it means is instead of going counterclockwise, you're going clockwise now. That's it. So you're going this direction. And here, let me help you break this down, okay? It's radian and it's a fraction. So look at the bottom number here. That is a 3. So that 3 there tells you how many times you split this pi into. Remember, pi is a half circle, so you split your half circle into 3 parts. Okay, so you have 3 parts there, all right? Now, if you split this half circle into 3 parts, each of them is going to be what degree? It's going to be 60 degrees, right? Because 180 split by 3 gives you 60 each. And then the top part, the 2 here, tells you how many of these little slices that you're taking. You're taking 2 out of 3. So there's 1, there's 2. I need to take this one right here. I need to go up to here. Okay, that's the angle I'm taking. So the rest of that can go away. And then I can, make my triangle by going toward the x-axis. And I'm looking for this x and y for this point here. Okay, so here I have a triangle that is 60 and 30 here. So obviously I'm going to have to use my 30-60 triangle, not the 45-45. Here again, you have to do that sort of rotation in your mind so you can know which side goes where. All right, so remember, the one that is next to 60 here, next to 60 is the short side. So this one is the short side. Away from the 60, across from the 60 basically, is the long side, long side. Okay, so I need to put these numbers in here. Okay, so however, because this one, the x is going to the left, so this x has to be negative. So instead of 1/2, I have negative 1/2 for x, and this y is going down. Instead of radical 3 over 2, I have negative radical 3 over 2. You guys pay attention to that, okay? If you go into the left, your x is negative. If you're going down, then your y is negative. Earlier, we were going to the right, so it's positive. Going up is positive, okay? So here, my x and my y are negative 1/2 for x and negative radical 3 over 2 for y. And I'm doing sine of this angle, so basically sine of the 60 here. So sine is opposite over hypotenuse. So opposite is radical 3 over 2, but negative over 1. So it's just this. So it's negative radical 3 over 2 for sine of negative 2 pi over 3. Okay. Another example, they want cosine of 5 pi over 6. This is positive, so I go counterclockwise, but 5 pi over 6. So again, look at the bottom number. That's how many times I split my pi into the half pi, the half circle here, split into 6. So there you go. I have 6 parts. And so if I split into 6, each of them has to be what angle, what degree? It have to be 30 each, right, to make 180. All right, each of them is 30, and I need to take 5 of them. Okay, so I go all the way up here to 5, and that's the one I need. Okay, 1, 2, 3, 4, 5, up to here. Up to here. So the rest of them can go away, and I make my triangle, and I'm looking for the x and the y there. All right, so again, I'm looking at the 30-60 because it's a 30-60-90. And let's see, the one next to 30 is the long one. So radical 3 over 2. And the one that is opposite is 1/2. Okay, but remember, this is going to the left. Your x is going to the left, so it's negative. And your y is going up, so it stays positive. It's not negative. It's going up, so it's positive. Okay, And I want cosine, right? Cosine is adjacent over hypotenuse. So adjacent of 30 is this, negative radical 3 over 2 over 1. So it's just this. So by the way, my x and my y come out to be, oh, that should be a negative. That should be a negative, sorry. Should be a negative radical 3 over 2. And so my answer is negative radical 3 over 2, okay, for cosine. One last example. They want sine of pi over 2. Look at the bottom number. The 2, I split my half circle into two parts, so 1 and 2, basically. So I go right down the middle, 1 and 2, okay? And I take 1, so I'm basically here. This is my angle right here. Now, how do I make a triangle out of this? If I draw straight towards the x-axis, it's just a straight line. There's no triangle, because that's right, there is no triangle, okay? I want you guys to visualize this way. Imagine if you had like a little angle down here. You have a little triangle. You see this base is long and the height is short, right? If this angle opens up a little bit bigger, so now it's up here, the base is a little bit shorter, it's still long, but the height is now longer, okay? You guys see what's happening? If the angle opens even bigger, the base is now short and the height is long, okay? Let's look at another one here. Look at that. Now the base is getting real short and the height is getting real long, okay? More, the base is super short now and the height is super long. Now, that's what's happening. You kind of open it up. As you go from this point up, the base gets shorter and shorter and the height gets longer and longer until you get to this point here. The base is now 0. My x is 0 and my y is 1. Okay, so I have 0 for x and 1 for y. The base is 0 and the height is 1. If I want sine, I'm looking at the height, right? Because that's the opposite. So remember, if you're looking for sine, you're always looking at the opposite over the hypotenuse, right? So opposite is the height. If you want cosine, you would be doing the base. But because I'm doing sine, I am looking at the height, which is 1. Okay, height is 1. So 1 over 1 gives me the sine of pi over 2 is 1. All right, if you were doing cosine, you would have 0 because the base is 0. Okay, the same concept applies to any angle that lies on the x and the y